Dear students of secondary certificate, welcome to Geology with Mr. Sabit, second episode, and we are going to explain what are the geological structures. The geological structures, we know that sedimentary rocks never stay as they have been deposited, but subjected from time to time to external and internal forces, which make the rocks take new forms and situations. These forms, known as geological structures. So, geological structures are sedimentary rocks subjected to internal and external forces that make the rocks take new forms and situations. There are two types of geological structures. There are primary structures and secondary structures. Now, what are the primary structures? These types of structures, remain in the rocks of crust under influence of climatic and environmental conditions, such as drought, heat, and the effects of wind and water currents. So the primary structures are structures influenced by the climatic and environmental conditions like drought, heat, effect of wind and water currents. Without any interference of tectonic forces or earth movements. So the factors affecting the primary structure are external factors like heat, wind, drought, water currents. As examples of such primary structures are cross-bedding. As we see here, cross-bedding, the figure in the middle. Ripple marks, the figure on the right. Graded bedding means that deposition starts from the pebbles or grains, then sands, then mud. Okay, that means the size decreases gradually upwards. These are considered the most important primary geological structures. Also, as I said, cross-bedding, ripple marks, graded bedding, and mud cracks. And everybody know mud cracks from drought. As we see here on the left figure. So these are considered the most important primary geological structures and the widespread, especially in sedimentary rocks. Number 2, secondary structures. The tectonic geological structures are being formed by forces emitted from the interior earth. So secondary structures are formed by the effect of interior factor from the earth. They are huge fissures, cracks, and violent torsions, which often we see deform the crust during our geological trips in mountains and deserts. Those internal forces that our planet Earth is subjected to. These forces, which cause earthquakes, damage of oceans and seas, transgression and regression of water on the land, and the continental drift. Their movements around each other. As well as make the rocks take forms other than those taken before, such as folds, faults, and fractures or joints, which deforms the crust. Now, folds. First, secondary structure, we are going to explain folds. The faults are considered one of the most important tectonic structures, and they exist clearly in sedimentary rocks, which appear on the form of layers, vary in their thickness and extension in nature from one place to another. Fault is known as bending or wrinkling happens to the rocks of the Earth's crust. It may be simple as single fold or often composed of several connected folds. It is often arising as a result of exposing the surface of the Earth's crust to pressure forces. So, faults may be single fold or composed of several connected folds. As we see in the figure, the fold here. What are the economic importance of faults? Faults are traps and reservoirs for oil, groundwater, and ores of minerals. I mean ores deposit on it. Number two, faults determine the chronology of rocks. I mean to determine the older and younger layers. Faults expresses or reflects the geological events. We see here faults in nature in the upper right figure and the structure of the fault. Although faults take different shapes, but the most familiar of all are those which are known as anticlines and synclines, and all share in some geological structures, or geological characteristics. So, most of the faults, which are anticlines and synclines faults, all share in some geological characteristics. Number one, they occupy different areas of Earth's crust, ranging from few meters to tens of square kilometers in the same region. And they are rarely found individually in nature. But when several faults are found connected together, uh, faults also rarely found in nature in definite shapes and systems, because faults are subject to repeat folding. We find that the majority of them may complicate the shape by fractures and cracks. So faults are found in nature with other structures like cracks, fractures, okay? Not single structure. Structural elements of faults. What are the structural elements of faults? Axial plane. Number one, axial plane. It is defined as imaginary plane, which divides the fold, into two equal and identical parts in all aspects. So, axial plane is defined as imaginary plane which divides the fold into two equal and identical parts in all aspects. Limbs. Number two, limbs. They are rock blocks which found on both sides of axial plane. Limbs found on both sides of axial plane. Axis, defined as line, imaginary line of intersection of the axial plane with any surface of all different layers. Since any fold always consists of succession of different layers, and each one of these layers has its own axis, then it is expected that the axial plane should contain all these axes. So each layer has its own axis. So if I have a fold includes 4 layers, so I have 4 axes. Each layer has its own axis. So the fold has 4 axes. There are 2 common types of faults: anticline faults and syncline faults. Anticline faults are characterized by the layers are concaved upward. The layers are concave upward, and its oldest layers are found in the center. So the anticline faults has layers concaved upward. The oldest layers are found in the center. The second type is syncline faults, which are characterized by the layers are concave downwards and its youngest layer are found in the center. So the anticline fault, the oldest layer found in the center. Syncline faults, The youngest layers are found in the center, as we see here in the two figures. Number two of the secondary structures, faults. Faults are considered to be one of the most important tectonic structures. The faults are defined as fractures of cracks, cutting rock masses, and accompanied by relative movement. I mean displacement of rock masses along both sides of fault plane. So faults are fractures, cracks, cutting rock masses, and accompanied by relative movement, relative displacement along both sides of fault plane. Fault structural elements, as we see on the right side figure here, the elements of fault, the fault plane, it is a plane on both sides. The fractured rock masses move with relative movement to each other, resulting in displacement. Number two, hanging wall. Hanging wall, the rock mass which found above the fault plane. So, the rock mass which found above the fault plane is hanging wall, Number three, foot wall. Of course, foot wall, the rock mass which found under the fault plane. So the rock mass found above the fault plane is hanging wall. The rock mass found under the fault plane is foot wall. So hanging wall above the fault plane, foot wall under the fault plane. Determination the type of fault. We must first know the direction of rock mass movement on one side of the fault plane. And according to the direction of the same rock mass movement on the other side of the fault plane. So the movement direction of rock mass on both sides of the fault plane determine the type of fault. Number one, normal fault. As you see here in the figure, the hanging wall moves downwards. Okay? Normal fault fracture is resulting by tension. So the hanging wall moves downwards by the effect of tension, where the hanging wall is moving downward along the fault plane with respect to those that occupying the fault wall. So the normal fault is caused by the tension, and the hanging wall moves downwards related to the foot wall. Number two, reverse fault. What is a reverse fault? A reverse fault is a fracture resulting by compression, where the hanging wall is moving upward along the fault plane with respect to those that occupying the foot wall. So, reverse fault is formed by the effect of pressure, the effect of compression, where the hanging wall is moving upward along the fault plane with respect to those that occupying the foot wall. As we see here, the hanging wall moves upwards. Three, thrust fault. So the fault number 3 here, thrust fault. What is thrust fault? It is a type of reverse fault. So it is a reverse fault, but is different than reverse fault, that the fault plane is almost horizontal with low angle of dip. The fault plane is almost horizontal with low angle of dip. So it is called creeping fault. So thrust fault is called creeping fault because its broken rocks almost creep horizontally for certain distance on the fault plane. So the broken rocks creep horizontally for certain distance on the fault plane. So thrust fault is a type of reverse fault, but the fault plane is almost horizontal, and the hanging wall creeping on this fault plane, as we see here in the figure. D, the fault number 4, strike slip fault. Strike slip fault, the rock mass moves horizontally in the same plane without vertical displacement. So strike slip fault, there is no vertical displacement. That means no upward, no downward movement of the hanging wall, but the movement is horizontally, okay, in the same plane without vertical displacement. Another type of fault is horsts. Okay, when the rocks are affected by two normal faults combine in foot wall. So when two normal faults combine in foot wall, this is horsts. It forms horsts. So horsts occur when the rocks are affected by two normal faults combining foot wall. Grabens, another type of fault. Grabens occur when rocks are affected by two normal faults combine in the hanging wall. So horsts, two normal faults combine in footwall by grabens, two normal faults combine in the hanging wall. The structures of faults and faults also appear in igneous and metamorphic rocks. So the structures of faults and faults also appear in igneous and metamorphic rocks, but are less clear than the appearance in sedimentary rocks. Because why? Because bedding features of the sedimentary rocks appear on the form of different layers, vary from each other in their thickness, extension, color, mineral and chemical composition, cementing material, texture, and fossils content. So, as sedimentary rocks are formed from layers in different shapes and composition, so faults and faults appear clearly in sedimentary rocks. The third type of secondary structures are joints. Joints are geological structures of tectonic origin. These are fractures present in different types of rocks, igneous, sedimentary, and metamorphic, without any evidence of movement. So, joints like faults, fractures, but faults has faults have movement, maybe vertical movement or horizontal movement. But joints have no movement. Fractures without any movement. The distance between joints varies from few centimeters to tens of meters, depending on the type of rock, the thickness of the rock, the method of response to rock to the forces affecting it. It was mentioning that the ancient Egyptians had benefited from the presence of joints in the rocks in their constructing temples and tombs, as well as making obelisks. So ancient Egyptians had benefited from the presence of joints in constructing temples, tombs, and obelisks. As you see here in the figure, compression and the tension forces in faults. Compressions of fault on the upper part of the layer, as we see here, but the tension force, the fracture takes the distance of thickness of the layer. We see here different directions of fractures, different directions of joints. There are strike joint, dip joint, tension joints. Okay. The economic importance of joints. Joints are filled up with economic mineral deposits like copper, nickel, and tin. Joints and rocks help people who work in mines because they are planes of weakness. So the importance of joints, we can find economic mineral deposits in faults, in joints, like copper, nickel, and tin. So, in the fractures of joints, we will find mineral deposits. Okay? Also, joints help people who work in mines because these joints are planes of weakness. Thank you so much for this session. Till we meet again. Bye bye.